A ball is thrown upward with a speed of 38 feet per second from the edge of a cliff that is 325 feet above the ground. Assume that the acceleration due to gravity is negative 32 feet per second squared. We're going to try and answer these two questions, but before we do, let's build our model of what's going on here. It's thrown upward at 38 feet per second, so that is the velocity at time 0, 38, because it's going up, and it's up on a cliff 325 feet above the ground, so that's our initial position. We're going to start at 325. Now it gives us the acceleration, which is negative 32, but we know acceleration is the derivative of velocity, so I can put that here, and we now have a differential equation to solve. So as we solve this, we undo it, since we're doing an antiderivative, so we're going to have the velocity equals negative 32t plus a constant, but our constant is the initial velocity, so we'll put the 38 in there. All right, now let's go ahead and get position, because we have velocity and we know that velocity is the derivative of position, so we can take that velocity equation, put it equal to ds dt here. And again, we're going to do the antiderivative, so we get s equals negative 16t squared. That was one higher power, reciprocal of the power there. And then plus 38t plus c, but our c is s naught, so we'll go ahead and just put that in 325. Okay, now that we have acceleration, velocity, and position, let's read what we want to find. Part A says, when does the ball reach its maximum height? Okay, so it's thrown upward and it's going positive, but gravity's acting on it. When it gets to its maximum height, the velocity will be 0 for that instant before it turns and goes the other way, when the velocity will be negative. So we need to know the place where the velocity is 0 to find the maximum height. And we actually don't need the maximum height. We're supposed to find when it reaches that maximum height. So we just need to take the velocity, figure out when it's 0, and find the time there. So let's move the 32t and then equals 38. So if we divide, we have t equaling 38, 32. And let's go ahead and round to 2 decimal places. So if we put that in, we get 1.18 seconds. In 1.18 seconds, it'll be at its maximum height. Now let's go ahead and answer part B. And part B says when, so it's going to want time again. When does the ball hit the ground? Well, the ball hits the ground if the position function is 0. So let's go ahead and take that position function, plus 38t plus 325, and put it equal to 0. And we're going to need to quadratic formula that. So t equals negative b, so that's going to be negative 38 plus or minus the square root of b squared minus 4 times a, which is negative 16, times c, which is 325. And that's all over 2a, and a was negative 16. So we'll get out our calculator now and punch buttons. And if we use the plus first from that quadratic formula, the positive one, it looks like we get a negative time. So that's not going to be the one that gives us that answer of when the ball is on the ground. So let's go ahead and use this quadratic formula again, but use the negative there. And it looks like we get to 2 decimal places 5.85 seconds. So it's back on the ground in 5.85 seconds.